Hi.
Hey, what's up?
Hi, David. Hi, BG.
Hi. Hello.
Yay, I think it's going to work today.
Yeah, it's so confusing.
I've got it on Google Air, so you should be able to turn in a recording today.
All right.
So I've invited Larissa and Kendra, too.
So it wasn't too bad this week, I think. So,
Yeah, I was going over a few things. Trying to figure out. I'm doing the homework. I'm doing the standard deviation for the four-sided die right now. Just trying to figure that out.
okay.
Get, get him some dinosaurs. Get some dinosaurs for him. Hurry. Um, we're supposed to have somebody in charge of each discussion. Do either of you guys want to do it today?
What do you mean,
Like in the email, he said that he wanted a driver. Just somebody to lead the discussion. Or he
oh,
had that
okay.
video. Did you see it?
I saw it, but I don't know, it's kind of a blur. But just someone to lead
Yeah, just have
um,
somebody in charge of
the
making
little hangout, kind of.
sure there's no dead time, I guess.
Yeah.
In charge, whatever.
Yeah.
So
So we're still waiting though, aren't we, on?
yeah, but I I copy and pasted everybody's email and invited them all. Um, so I don't. Let me see if I can add them again. I'll invite them one more time.
Okay.
It says my invitation's been posted, so we'll see what happens. Go get some cars.
You guys see that Cardinals game? There's a beat down on the 49ers. It's good.
Nah, I'm not. I'm not. I don't really follow it, so
My
yeah.
husband does, but I was busy doing other stuff while he was watching it.
Oh,
Give him some toys. Well, should we get started or should we wait?
Have they? They have your number as well? They haven't.
Let's see. Um, I have Kendra's.
Because We could get started as well, because last time we were here for what, like 2 hours?
Yeah, I don't want to be on. I don't want to be on that long today.
Me either, yeah. I don't think any of us do. Yeah. And I don't think he'd like watching a 2 hour video.
Yeah, so that's why I'm glad we didn't. Kind of glad it didn't get recorded last time.
Yeah.
So maybe let's. I've just asked Kendra if she's coming on. Do you guys have the? I need to pull up. Maybe I've got to find Larissa's phone number. If you guys have it, I'll go look in my folder.
Okay.
I have it in my old phone, but
You have what?
I have it in my old phone.
Let's see. I'm gonna invite him again.
If you want, we can go over like the first 4 on part 1. If you guys have any questions, then we can just when they're joining.
Let's do that while we're waiting.
You guys want me to start, and then we can just
Kind of rotate off, I guess, yeah.
This says number 1. It says what notation is used to denote the probability of an event occurring. And it's just P times X in parentheses.
Right.
Yeah, that's P is just for probability, and then X is just whatever you're trying to solve. That's it.
Yeah.
I'll do the next one. It says, please state and describe the 3 rules of probability. And I like the example they had better to explain the rules than the actual rules that they had written down. Basically, he's saying you can't have it be a negative number. It can't be over 100, and and all the numbers need to add up to 100.
Yeah.
Yeah. So, just number 3, what does it mean to be random? Basically, it follows a long-term pattern, but you don't know the outcome of the next experiment. So it's just a pretty long pattern, I guess. Just kind of random, and you don't know the end experiment to it. Yeah.
Yeah, there's always going to be a pattern. You can't
Yeah.
randomly kind of pick stuff. There's always going to be a pattern.
Yeah.
Yeah. And then number 4, this one was kind of hard. I couldn't really figure out what the what the phrase discrete random variable mean. And I just put value could be listed, given enough time, but you gotta roll the dice enough times, or you gotta give whatever experiment you're doing enough time to be able to like list your values. But that's what I got. But I don't know if it's right or not.
Well, when I was figuring it out, there's 4 sides, so there's 4 like values. Is that what you would call it?
Mhm.
So I wrote down a little chart for the value, and then you had to figure out the count. So say you rolled them 4 times each, you have 4 chances, and like they were saying, what you had to do is you take let's see, in the reading, like, see, I'll write it down. like in the dice, it showed how many times that they rolled the dice, and it was like in the thousands, you know. And all
Yeah.
together, they rolled all the dice, whether 1, 2, 3, or 4. All together, it was 6,000 times. So if you rolled 4 dice 4 times, all together, it would be 16 times. So you have to go 4 divided by 16 is 0.25.
Mhm.
Is that for number 5 or number 4?
Oh, we're doing number 5.
Oh no, I was doing number 4. That's just because that's the same answer for number 5.
Oh, sorry. I was like, that's not what I got. I actually got an answer. Okay. Well, should we do number 4? I wish those guys would come on.
Yeah. Mhm.
I'm calling Kendra. Do you guys want to get on the
Yeah,
line?
I'll call Larissa real quick.
Okay. Okay, I just got her answering machine, so
Okay.
I don't know. They might have to meet up at a different meeting together.
Yeah, we should
Well, she
probably.
texted me last night. Are we getting together at 9 in the morning? I said yes. And then I emailed everybody last night.
Mhm.
So
Yeah. Yeah, we could probably get going on the
okay, well,
group stuff.
when David comes back.
Yeah.
All right, yeah, she didn't pick up, so.
Okay, yeah, neither did Kendra. So let's just start with number 5 then.
Okay. Yeah, I think everything you just said is like that's exactly what I did. I drew out like a little chart, like kind of just like this. I don't know if you guys can see it, but kind of just like the possibility of it to get rolled was a quarter, was like 0.25, and then I just multiplied it by 2, 3, and 4, and it came out to 2.5. I guess I could have done it like you guys did it, where we just divided it all by 4 divided by 16.
Okay.
Mhm.
But yeah, that's what you got was 2.5 was the sum of all the.
Yeah.
Was 4 divided by 16 was 0.25, and 1 times that, 2 times that, 3 times that, 4 times that.
Mhm.
Okay. So now to do the next question, standard variation or the standard deviation, you have to have that sum.
The mean, right, of the discrete
Yeah,
random variable. Yeah.
which was 2.5, right?
Uh-huh.
So you would go 1 minus 2.5, right? You'd go through
Yeah.
all those. So 2.
You have to You have to square it, don't you?
Well, I think you do that. You go 1 minus 2.5 and then you square it. So 1 minus 2.5 was 1.5, and then you square it. Would give you 2.25, right? You guys get that?
Yeah.
I'm right now, yeah. Yeah, I see it. Like I went over the key, and I couldn't really understand like the equation, but I was going over the key trying to figure it out, and so I'm just trying to follow along with you guys right now.
Okay, well let's just do it from the top. So write down all your variables, or the what do you call this? The value, the numbers that are on the die.
Yeah, I get like the value or.
So write down 1, 2, 3, and 4, and then on each of those I'm putting minus 2.5. That was the
2.5.
That was the mean.
The mean.
What's the definition for that? What would you call it?
Of the what?
The discrete random variable.
Oh yeah, the mean of the discrete random.
Okay, so we'll just do it together on our calculators. 1 minus 2.5 was negative 1.5. And then you square it or times it by itself. Let's see. One minus. So it will be a positive 2.25. And then the next one is 2 minus 2.5 is a negative 0.05. And then you square it, and it's a 0.25.
Mm-hmm.
Okay, and then 3 minus 2.5 is 0.05, and then you square it. Wait a minute. What'd you guys get?
Or
Number one was 2, right? 2 even? Or 1?
Now what?
The first one was 2 even, right? The answer?
I got 2.5. 1 minus 2.5 it's a negative 1.5, and then you square it, so it's 2.25. So if you went negative 1.5 times a negative 1.5, you get 2.25.
Okay. I'm getting on now.
yeah.
I'm touching on now, so yeah.
Okay. So on the number 2, you got 0.25.
Yeah, so I just put like 2 minus 2.5 squared, right?
2. Yeah.
Yep.
Whatever that outcome is so that'd be 0.5. 2 minus 2.5 is just 0.5 squared times 1, and then you multiply that by 0.25, right? So it just comes up to 1.25.
Let's see. No. 2 minus 2.5 is going to be negative 0.5.
Yeah.
And then you square it. You square the negative 0.05, and you should get 0.25 for the answer. 0.25.
Okay.
Okay, so the next one, 3 minus 2.5. is 0.5, and you're going to square the 0.5. And I got the same answer. Did you guys do that?
Yeah.
Okay.
And now 4.
Yeah, 0.25 for number 3.
Yeah.
So
For the fourth one is 2.25 again. So, are we caught up that far?
Mm-hmm.
Okay, so then you're going to take all those answers and you're going to times it by the probability of the value. So, wouldn't you do like 2.25 times 1 over 4?
Yeah, 1 over 4, just 0.25, right?
Yeah, just 0.25.
So you do all of them times 1 over 4. No. You can't. Or you times all of them by 0.25. All these answers we just got. Right?
Yeah.
Mm-hmm.
Okay, 2.25 times. So the first one should be 0.563. Did you guys get that?
Yeah, and that's the same for number 4, right? Number 4 is the same as that?
Yeah.
Mm-hmm. Yeah, I got that.
And then number 2 and number 3 are 0.25 times 0.25, right?
Yeah. I got 0.063 if you're going to round it to the nearest decimal.
Yeah.
Okay, so now from there, we have those answers. Now, what do we do from there?
We add them? Do we?
Yeah, you add the sum of all of them. Okay, so 0.563 plus 0.063 plus 0.563 plus 0.063. Okay. So I got the sum as 1.252.
Yeah.
Mm-hmm.
And then we have
you do the square root of that?
Yes.
Square root of that. Wow. I got 1.1197. Is that right?
1.119.
Yeah, that's what I got. So you're gonna go 1.2. You're gonna, if you do it in your calculator, you'll do the square root symbol and then put in 1.252.
Yeah.
Should give you 1.11, and if you round it, it's 9. 1.119.
Yeah.
So that is the standard deviation.
Mm-hmm.
Okay. I hope that's... Let's see. You guys have the answer key. Did we get that right?
The standard deviation, it just says square root 1.25, and it comes out to be 1.118.
1.118. Okay, so they didn't
Mm-hmm.
round it. Okay. So we're on the right track anyway. Okay, let's do our... Oh, that's all. So let's do our quiz.
Oh yeah, let me have a quiz too.
Quiz.
Let me know when you guys have it open.
All right. Everyone have it open?
David, did you have it yet?
I'm getting it on Island right now.
Okay.
No, because you did that.
I got an email from Larissa. She says, I can't do the meeting today. I've been really sick.
Oh, okay.
So I don't know about Kendra.
All right, I have my quiz open now, so.
Okay.
Okay, so I'll just read the first one.
Okay.
So it just says note, give all your probability answers as decimals. For example, 0.1234. Do not give probability answers as percents. Human blood can be classified into one of our basic types O, A, B, and AB. The proportion of people in the population of the United States with each of these blood types is summarized in the following table. Blood type O, proportion 0.5, A, 0.40, B, 0.11, AB, 0.04. Using this data to answer the following questions, the blood types and the proportions given in the table above define a probability distribution.
True. I think it's true. It's showing that that's the probabilities. Probability of a type O is 0.45, or if you turned it to a percentage, it'd be 45% probability that you are type O. So wouldn't it be true that that's what it's showing?
Yeah.
Either that, or you could use it as like an equation. Like if you had like 20 people and it said what percentage of these people could have AB blood, 0.04% of them, right?
Yeah. Just one thing, like you want to make sure to just like follow the rules, so just make sure they add up to 1, which they do. But
Oh yeah, huh?
yeah, because you could say
You could say it's a negative, or
yeah, because you could say it is a probability distribution, but if it didn't add up to 1, then it would be false. So
right. Good point.
yeah.
Yeah, it was
So
a
yeah, it's true though.
3%, 4%, and 5%. It wouldn't be.
Hmm. Yeah, but
So,
it's true.
okay. So number 4, what is the probability that a random selected person in the United States has a type O? I just said, and it says round 2 decimal places, which is, it is what it is. It would be 0.45.
Mm-hmm.
Okay.
4.
What is the probability that a random selected person will not have type O blood? So that would just be 55.55, right?
Yeah. Okay.
Okay. Carolyn Willis and her colleagues conducted a study in which dogs were trained to detect bladder cancer. The dogs were trained to lie down next to a specimen derived from a bladder cancer patient. Tangle, one of the dogs, demonstrates the identification of a specimen. 7 bowls containing urine were lined up in a random order. 6 of the samples were from the patients who did not have bladder cancer. One of the samples came from a person identified as a bladder cancer patient. If the dogs guess at random, what is the probability that they will correctly identify the dish containing the specimen for the bladder cancer patient? Round answer to 3 decimal places.
So they'd have a 1 in 7 chance of guessing it. Right?
Yeah.
You have to do 1 divided by 7.
1 divided by.
I got 0.1428.
0.1428, yeah.
Or actually 0.1429, but yeah. 0.143, is that what we're gonna go with?
Yeah.
0.143. Okay. So the next one is in a combined trial, or a combined total of 54 trials. The dogs correctly identified the specimen from the cancer patient 22 times, so 22 out of 54. It is very unlikely that the dog would do well by random chance alone. Which of the following statements is most appropriate? Well, that's less than half. Less than half of the times they got it right. It says there, it's either, wow, this kid. Let's see, there is little evidence that the dogs can detect bladder cancer, or this provides strong evidence that the dogs can detect bladder cancer. Well,
I don't know. It's like a toss up. It's like you said. They got it less than 50% of the time, but then again, they also got it 22 times.
well, if I was wanting a dog to, if I was counting on the dog to detect that, I would say there's little evidence. I'd want it to be a higher probability than that.
But even though there is only one person out of all the samples, out of 7, would it still be considered that it's little evidence?
Now, say that again.
So, just because it may be that it's little evidence that the dogs can detect bladder cancer, but because in the trial or in the experiment you only have one person that has a bladder bladder cancer.
Well, this one it said, let's see. Oh, let's see. Dogs. Okay, so yeah, they're testing the one patient. But he still only got it 22 times right out of 54.
Yeah.
It says right here, it is very unlikely that the dog would do this well by random chance alone. Just a minute.
I think it's A. I think you said.
Alright. So the little evidence that dogs can detect bladder cancer.
But I don't know. I don't know. It's very unlikely that the dog would do this well by random chance alone. Let's come back to that one.
Yeah. Alright. So M&Ms are small chocolate candies. The M&Ms website previously indicated that in the United States, the distribution of the colors in a bag of plain M&Ms is given in the following table. If you reach into a bag of plain M&Ms, what is the probability of drawing a red colored candy? Round answer to 2 decimal places. Red.
0.13. I like
Yeah.
these questions better.
Yeah.
So
What
I
is
added
the
it all up for number 9, and it'd be 0.16
It would be.
for the green.
What would it be?
0.16 because all the other ones add up to 84.
So
Okay.
0.16?
Yeah, 16.
Oh, okay.
I'm just gonna I'm gonna check it too, just because.
Yeah.
Don't.
What's up? Good.
Did you got 84?
My brother don't have it. Y'all call me up.
So you
Yeah,
put the answer 16?
Yeah, it was 84. So yeah,
Oh, but
6
it's 0.16, right?
points. Yeah.
No, I'll call him today too, see if I can hold him this time.
What is the probability that a random selected candy is not green? So just like you said, 84.8.
Point.
I'm just doing some homework right now, so. Hold in just a little bit.
Okay, so
Sorry guys. Did we already, are we doing number 10 right now?
Yeah, it was like you said. It's 0.84. They wanted to know what the probability that he would not choose green.
Oh, yeah. Okay.
Okay, next one.
all right. The ACT scores of a student admitted to a medium-sized public university in the Western United States were taken from Capex.com. The following summary statistics were calculated. Half of the observations are less than or equal to what number?
24. That's the median. Right?
24?
It says half the observations are going to be less, so the halfway point is the median, which is 24. So half is going to be less than that or equal to that.
Yeah.
Is it going to be 24.3 or just 24?
It's a plain 24 because that's what the chart says. Mine does. It says 24.
Yeah.
Okay.
Based on the information on the table above, the top 25% of students scored above what number?
So that's quartile 1.
Yeah.
So they scored above 22.
22.
Which of the following statements is not one of the 3 rules of probability? For the sum of the probabilities in any probability is 1. That's true. The probability that an outcome will not occur is 1 minus the probability that it will occur. What?
That's
Probability.
true.
Yeah,
that's true.
Explain that to me. I'm not getting that. Probability that an outcome will not occur. Oh, I get it. It's just what we did with the M&Ms. Okay.
Yeah, that one was weird. It's the definition I gave like in the book, but it was a little difficult to understand.
A probability is a number between 0 and 1.
True.
Because, yeah, it's a fraction. It's either going to be
it's going to be B. B's got a negative. It says if the probability is low, then the probability is negative. I don't know.
False.
So that one's not true, the last one. the probability is low, then the probability is negative. Yeah, there can't be a negative.
Yeah.
So the last one is the one that is not true. Or I shouldn't say that, because your screens might be different.
Yeah.
It says if the probability, it's the one that says if it's low, it's negative. That's the one. Okay.
Yeah.
So
What's up?
I was going to say back to the dog.
Yeah.
It's very unlikely. I'm not. So they're saying that if they had just a bunch of people, they're saying that if there was a bunch of people, he probably wouldn't do that well.
Mm-hmm.
So it's little evidence. That's what we agreed on? Okay.
Yeah, little evidence. All right.
Okay. I want you to do good on this test. Okay. So, if you guys don't mind, I like to go over them to make sure I haven't done anything wrong.
Yeah, that's fine.
Okay, so number 3, we put true.
Yep.
Mm-hmm.
Number 4, we put 0.45.
Mm-hmm.
5 is 0.55. Right?
Yeah.
Yes.
6 is 1.143.
Yes.
Yeah.
There's little evidence. 8 is 0.3. 9 is 1.6. 10 is 0.84. Gotta make sure you put the decimal in. Okay, and then the number 11 was 24. Number 12 was 22. And then we said that the negative answer was the wrong one.
Yes.
Yeah.
Okay, I'm gonna submit it then. We got one wrong. It's the dog one, I know it.
Yeah.
Oh my gosh. I don't know. That was a tricky one. Yes, it is pretty. I mean, I don't know. You guessed that many times. I mean, if you think about it,
Oh.
real life, it really probably is pretty good evidence that they can do it that many times.
What did you guys get for number 12?
That was wrong too.
Oh, it was?
Yeah.
What? Oh my gosh, I think we had to do the opposite.
The top.
Make some information. The top 20.
45.
The top 25. Oh, so it's going to be the third quartile. The top 25 is above
the 75%.
75 mark.
Yeah.
Oh, dang it.
Oh, so then it would have been 27. Yeah.
We need to read but that dog one. Come on.
Yeah. Yeah, that's what I thought. Just because it was like, because you only had one person with the bladder cancer, so in reality, it kind of does support it. Strong evidence.
I mean, because if in real life I had a dog out here doing that, I'd think, wow, that's really good.
Yeah.
So.
All right. Yeah. I guess we just gotta read them a little better.
Yeah. Hey, we got most of them right.
Yeah.
You have to be real dummies to not read the charts right, but I guess we was when we didn't do the 75th one.
Yeah.
Okay.
All right.
So this is gonna work. I'll have to see what happened to Kendra, but this should be recorded now, and we'll be able to submit it. And we didn't go 2 hours today, so that's awesome.
Yeah. All right.
Hey, well, we'll see you guys Thursday morning then.
Thursday. All right.
All right, guys. Have a good
You guys.
Okay,
Bye.
see you later.
Bye.